Hello students, and welcome to the lecture on array and pointer. After the lecture, we will be able to learn the following objectives. Describe the definition of arrays and one-dimensional arrays. Explain the accessing array elements. Discuss array manipulation. Describe the two-dimensional array. Define the null terminated strings and array of characters. Explain pointers. Describe the relationship between array and pointer. Discuss the scaling up of the concept. Let's start with a brief introduction to array and pointers. Arrays are not pointers, and pointers are not arrays. Pointers in C hold a single address in memory. Arrays are contiguous blocks of memory that hold multiple like-kind objects. A pointer is a variable suited for keeping memory addresses of other variables. The values you assign to a pointer are memory addresses of other variables or other pointers. Pointers are one of the most powerful and confusing aspects of the C language. A pointer is a variable that holds the address of another variable. C pointers are characterized by their value and data type. The value is the address of the memory location the pointer points to. The type determines how the pointer will be incremented or decremented in pointer or subscript arithmetic. Relation between arrays and pointers. In arrays of C programming, the name of the array always points to the first element of an array. An array is a collective name given to a group of similar variables. An array can be one-dimensional, two-dimensional, three-dimensional, and so on. Let's now take a look at one-dimensional arrays. The declaration form of one-dimensional array is as shown here. On the screen is declared an array called numbers to hold 5 integers and sets the first and last elements. C arrays are always indexed from 0, so the first integer in the numbers array is number 0, and the last is number 4. The array contains 5 elements. Any of these elements may be referred to by giving the name of the array followed by the position number of the particular element in square brackets. The first element in every array is the 0th element. Passing one-dimensional array in function. C program to pass a single element of an array to function is as shown on the screen. Output. Single element of an array can be passed in similar manner as passing variable to a function. Passing entire one-dimensional array to a function. Let's look at a C program to pass an array containing the age of a person to a function. This function should find the average age and display the average age in the main function. Output. Average age is 27.08. Let's now have a look at the definition of arrays. An array is a group of variables of a particular type occupying a contiguous region of memory. In C, array elements are numbered from 0, so that an array of size n is indexed from 0 to n minus 1. An array must contain at least one element, and it is an error to define an empty array. Arrays are data structures which hold multiple values of the same data type. Arrays are an example of a structured variable in which there are a number of pieces of data contained in the variable name, and there is an ordered method for extracting individual data items from the whole. C programming language provides a data structure called the array, which can store a fixed size sequential collection of elements of the same type. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element, and the highest address to the last element. Array initialization. As for any other type of variable, arrays may have local, external, or static scope. Arrays with static extent have their elements initialized to 0 by default, but arrays with local extent are not initialized by default, so their elements have arbitrary values. It is possible to initialize an array explicitly when it is defined by using an initializer list. An array is a list of values of the appropriate type enclosed in braces and separated by commas. Let's now take a look at how to access the array elements. An element is accessed by indexing the array name. This is done by placing the index of the element within square brackets after the name of the array. Let's see an example on the screen which will use all of the three concepts, that is, declaration, assignment, and accessing arrays. Output of the program is on the screen. Let's now understand array manipulation. Almost every C program contains an array, and almost every C programmer has made his or her share of array programming errors. Two of the most troublesome kinds of array errors are array reallocation errors and algorithmic array errors. Searching for an element in an array. The implements of linear searching algorithm, is used to find whether a given number is present in an array, and if it is present, and then at what location it occurs. It is also known as sequential search. For a better understanding, let's look at an example. Output of the program is as shown here. Let's now learn about insertion of an element in an array. For example, consider an array A of 10, having 3 elements in it initially, and array A of 0, which has 1, array A of 1, which has 2, and array A of 2, which has 3, and you want to insert a number 45 at location 1, i.e. array A of 0, which has 45. So we have to move elements one step below. So after insertion, array A of 1, which has 1, which was array A of 0 initially, and array A of 2, which has 2, and array A of 3, which has 3. Array insertion does not mean increasing its size. The array will not be containing 11 elements. Let's see an example on the screen. Output of the program is shown here. Now let's have a look on how to delete an element from an array. Deleting an element does not affect the size of the array. It is also checked whether deletion is possible or not. If an array is containing 5 elements and you want to delete element at position 6, then it's not possible. Let's see an example of deletion of an element from an array on the screen. Output of the program is as shown here. Let's now understand how to find the largest, smallest element in an array. Let's see an example on the screen which shows the largest element present in an array. It also prints the location or index at which maximum element occurs in an array. Output of the program is shown on the screen. The smallest element present in an array. It also prints the location or index at which minimum element occurs in an array. Let's now learn about two-dimensional array. The simplest form of the multi-dimensional array is the two-dimensional array. A two-dimensional array is, in essence, a list of one-dimensional arrays. To declare a two-dimensional integer array of size x, y, you would write something as shown on the screen. Where type can be any valid C data type, an array name will be a valid C identifier. A two-dimensional array can be thought of as a table which will have x number of rows and y number of columns. A two-dimensional array A, which contains 3 rows and 4 columns, is as shown on the screen. Accessing two-dimensional array elements. An element in two-dimensional array is accessed by using the subscripts, i.e. row index and column index of the array. Let's see an example on the screen. Output of the program is on the screen. Let's now have a look at matrix representation. Matrix representation is a method used by a computer language to store matrices of more than one dimension in memory. Fortran and C use different schemes. Fortran uses column major, in which all the elements for a given column are stored contiguously in memory. C uses row major, which stores all the elements for a given row contiguously in memory. If most of the elements in a matrix have the value 0, then the matrix is called spare matrix. Let's see an example on the screen. Here we will discuss null terminated strings, an array of characters. In C, a string of characters is stored in successive elements of a character array and terminated by the null character. Let's see an example on the screen in which the string hello is stored in a character array. Null is defined as a macro to be 0 in stdio.h, so programs can use the symbol null in expressions if the header file is included. The remaining elements in the array after the null may have any garbage values. Let's now take a look at termination by null by the compiler as shown on the screen. Let's now take a look at pointers. Some C programming tasks are performed more easily with pointers, and other tasks, such as dynamic memory allocation, cannot be performed without using pointers. Every variable is a memory location, and every memory location has its address defined, which can be accessed using ampersand operator, which denotes an address in memory. Let's see an example which can print the address of the variables. Output of the program is on the screen. How to use pointers. There are few important operations which we will do with the help of pointers very frequently. We define a pointer variable, assign the address of a variable to a pointer, and finally access the value at the address available in the pointer variable. This is done by using unary operator pointer, which returns the value of the variable located at the address specified by its operand. Let's see an example on the screen. The output of the program is on the screen. Pointer operations. C offers several basic operations you can perform on pointers, and 8 of these possibilities are assignment, value finding, dereferencing, taking a pointer address, adding an integer to a pointer, incrementing a pointer, decrementing a pointer, differencing, and comparisons.
We're continuing where we left off with operations on pointer variables. Basically, the operations that are allowed on pointer variables are the assignment and relational operations and some very limited arithmetic operations. And the value of one pointer variable can be assigned to another pointer variable of the same type, such as integer to integer, double to double, so on and so forth. Two pointer variables of the same type can be compared for equality, and so on, and integer values can be added and subtracted from a pointer variable. Now, the value of one pointer variable can be subtracted from another pointer variable as well. So take, for example, what we have, this first declaration here, declaring two variables. We're calling them P and Q. The statement P equals Q basically copies the value of Q into P. And after this statement executes, both P and Q will point to the same memory location. Any changes made to the pointer P automatically change the value of the pointer Q. Now remember, these are pointing to memory locations. So this expression here, P equals Q, and I just put this in an if statement which does nothing, but just for explanatory purposes, this will evaluate to true if P and Q have the same value, or that is if they point to the same memory location, which in this case they do because we assigned Q into P. Similarly, we can check for the relational, if it's not, if they don't point to the same. This will evaluate to true if P and Q point to different memory locations. The arithmetic operations that are allowed differ from the arithmetic operations on numbers. So we can use the following statements here to explain the increment and decrement operations on pointer variables. And let's go ahead and comment this out real quick, just so it will compile. Okay, and we're going to compile or run it, and it's not really going to do anything, but just to show you that it does compile. Anyway, so given these declarations right here, we have declared four pointer variables: one of type int, one of type double, one of type char, and one of type student type, which is our struct up here. Now this statement here will, or actually these both statements here will do the exact same thing, but they increment the value of P by 4 bytes because P is a pointer of type int. Now remember, integer variables will have 4 bytes of memory, or they will take up 4 bytes of memory. A double will take up 8 bytes. So this statement here, Q plus plus, because it's a double, will increment the value of Q by 8 bytes, and the value of the character pointer variable by 1 byte will be incremented by 1. And because characters only allocate 1 byte in memory. Now the student pointer here will increment the value of student pointer by 40 bytes. This is all in memory. The increment operator increments the value of a pointer variable by the size of the memory to which it is pointing. So whatever you're working with, you need to keep that in mind. And similarly, the decrement operator will decrement the value of a pointer variable by the size of the memory to which it is pointing as well. And more along those lines, this statement here, P equals P plus 2, increments, the value of P by 8 bytes because we're adding 2 to it. The first one would be 4 bytes, plus 2 would be 8 bytes, plus 3 will be 12 bytes, so on and so forth. And now, when an integer is added to a pointer variable, the value of the pointer variable is incremented by the integer times the size of the memory that the pointer is pointing to. Similarly, when it's subtracted, the value of the pointer variable is decremented by the integer times the size of the memory to which it is pointing. Now, something to keep in mind, this is really important, pointer arithmetic can be very dangerous. Using pointer arithmetic, the program can sometimes accidentally access memory locations of other variables and change their content without warning. And this will leave the programmer, when you're debugging, you'll be trying to find out what went wrong. You could be lost here. If a pointer variable tries to access either the memory space of other variables or an illegal memory space, some systems might terminate the program with an appropriate error message. So you always want to be careful just when you're using pointer arithmetic. That's all we're going to cover for today. It's been a short video. Let's go ahead, and we're actually going to get, because we're trying to use P without it being initialized, we might get an error. Yeah, okay.
Let's now have a look at the void pointer. A void pointer is nothing but a pointer variable declared using the reserved word in C, void. Let's see an example of a void pointer on the screen. When a pointer variable is declared using keyword void, it becomes a general purpose pointer variable. Address of any variable of any data type, char, int, float, etc., can be assigned to a void pointer variable. A void pointer can be really useful if the programmer is not sure about the data type inputted by the end user. In such a case, the programmer can use a void pointer to point to the location of the unknown data type. Null pointers in C. It is always a good practice to assign a null pointer to a pointer variable in case you don't have an exact address to be assigned. This is done at the time of variable declaration. A pointer that is assigned null is called a null pointer. The null pointer is a constant with a value of 0 defined in several standard libraries. Let's see an example of null pointers on the screen. Output of the program is on the screen. Let's now learn about the relationship between array and pointer. Arrays are closely related to pointers in C programming, but the important difference between them is that a pointer variable can take different addresses as value, whereas in the case of an array, it's fixed. An example is shown here. Output of the program is shown on the screen. Let's now take a look at scaling up the concept array to array multidimensional array. C programming language allows the programmer to create arrays of arrays known as multidimensional arrays. For a better understanding of multidimensional arrays, let's see an example on the screen. Here is an array of 2 dimensions, which is an example of a multidimensional array. This array has 2 rows and 6 columns. Let's now take a look at a C program to find the sum of 2 matrix of order 2 cross 2 using multidimensional arrays where elements of matrix are entered by the user. Output of the program is on the screen. Array of pointers. Just like an array of integers or characters, there can be an array of pointers too. An array of pointers can be declared as shown here. For a better understanding of an array of pointers, let's look at an example. Output of the program is shown on the screen. Pointer to a pointer. As the definition of pointer says that it is a special variable that can store the address of another variable, then the other variable can very well be a pointer. This means that it is perfectly legal for a pointer to be pointing to another pointer. A pointer P1 that points to yet another pointer P2 that points to a character CH. In memory, the 3 variables can be visualized as shown on the screen. For better understanding of pointer to a pointer, look at the example on the screen. The output of the program is shown on the screen. Pointer to function. Just like pointer to characters, integers, etc., we can have pointers to functions. A function pointer can be declared as shown here. To understand more about pointer to function, let's look at the example. Output of the program is as shown on the screen. Now in the end, let us summarize what we have learned in this lecture. Arrays are closely related to pointers in C programming, but the important difference between them is that a pointer variable can take different addresses as value, whereas in the case of an array, it's fixed. An element is accessed by indexing the array name. This is done by placing the index of the element within square brackets after the name of the array. Deleting an element does not affect the size of the array. It is also checked whether deletion is possible or not. For example, if an array contains 5 elements and you want to delete element at position 6, then it's not possible. Pointers in C are easy and fun to learn. Some C programming tasks are performed more easily with pointers, and other tasks, such as dynamic memory allocation, cannot be performed without using pointers.